All right, here we are again with some logs and graphing. Well, up to this point, we've seen what we call the parent function. There was two of them. Really, in reality, it really depends on your base. This is very similar to exponents because where did log come from? Exponents, right? It comes similar to exponential graphs. If whatever your log base is, that's your starting point. So classic example here, log base 5, right? We flipped it over, or we created an exponential function out of it, and then we graphed it. It was a little backwards as x was the exponent. But now we can take those and we can perform the same transformations we've done all year long. We can shift it to the left and the right. We can move it up and down. We can stretch it. We can shrink it. We'll probably focus on the up, down, left, and right this time, but you can add some shrinks and stretches on the outside. But let's take a look at each one of these. Recall that if something is in the parentheses, that's a left and right transformation as it's centered around the x, and the x-axis is left and right. If it was on the outside, say for example C here, that would be up and down as it is more around the y, which is the y-axis. Even though logs are a little bit backwards, if you know what I mean. They've got the exponent in there, we're choosing the y values, that still follows in the transformation. So let's take a look at A here. We've got y equals log base 3 of x minus 5. We could create a straight out table for this and try to plug in values. But what I think I'm going to do is I'm actually going to start with the parent function, y is log base 3 of just x, just that guy, okay? And if you happen to have two colors, I recommend you do two colors. So I'm going to write this first one in purple because we've already done this one. We just did it in a video, like the last video. So here we go. We know the table for this one pretty well. -2, -1, 0, 1, and 2. What is 3? So we've got 3 to the x equals y when we flip it back, right? What is 3 to the 0 power? That would be 1. What is 3 to the first? 3. What is 3 to the second? 9. Now what happens if I take that 3 and I turn it upside down with a negative power? I get 1/3. What happens if I take that 9, I turn it upside down? I get 1/9. And so here is my parent function, my very first function here. I like to start with 1, 0. It's a nice anchor point. And then a little bit, out 3, up 1, out 9, up 2. And we have this purple line here. Now, if you're not working in two colors, go ahead and call this, I don't know, f of x. And we'll label this f of x. Now, let's call this one g of x, okay? We're going to call that one g of x because this is not the graph that they asked us to make, right? They didn't ask us to graph log 3 of x. They asked us to grab log 3 of x that has been shifted right 5 units, right? The x has been pushed 5 units to the right. So each one of these dots that I just created, I'm going to push it over 5 to the right. Well, the 9 one goes off the page, and so that's not very helpful. But I can take this guy, go over 1, 2, 3, 4, 5. There he is now. 1, 2, 3, 4, 5. Now careful, this next one is not on that line, so I don't want to place him on this new line either. I'm going to go over 1, 2, 3, 4, 5 to about 5 1/3. You see that? And then I also want to go over to 5 1/9. And what we see is this function shifted right 5 units. This is g of x. As long as you label as such, you're good. If you're doing it on the computer, you feel free to plot your parent function, then actually drag and drop those points 5 units to the right. If you feel like you don't want to draw the parent function just 5 units to the right, that's fine too. But it's very easy to just drag it over 5 as well. All right, the asymptote of this function is not x equals 0. Check out that red one. The parent one, yes. The purple one, it is centering around 0. But where is this one floating around now? This one has been moved over, and we are looking at the asymptote of x equals 5. It's actually centered around 5. When you shift all of that stuff right 5, you drag that asymptote as well. And you want to make sure that you kind of mention that if it asks. All right, let's try another one. This one is very similar, also inside. So we'll go ahead and draw ourselves some axes. Also inside that parentheses, which means that it is also centered around x, which means that it is also a left or right function. But since this one is positive, this one will be going left. Remember that that is always kind of another inverse relationship of itself, right? The right one you would think would be the positive, but in fact it is the left that is the positive, the right is the negative, something that has been consistent amongst all these functions. But right now, let's not focus on that. Let's just graph, log 4 of x. So what would that look like? That would look like 4 to the y is equal to x. Have not done this one before, so let's go ahead and make our table. -2, -1, 0, 1, 2. People always ask, how do you know how to choose those y's, Miss K? I don't. I choose things that are around the center here so I can get a nice pretty picture. You don't have to choose those. You can choose whatever you feel like. But I do highly recommend you get both negatives, positives, and maybe 0. That way you get all sides of the graph. All right. 4 to the 0, 1. 4 to the first, 4. 4 to the second, 16. Cool. So now I'm going to take 4, flip it over, 1/4. 16, flip it over, 1/16. So what am I doing? Once again, 4 to the second is equal to 16, which is how I got 16/2. Unfortunately, 16/2 is off the page though, so that's not really something I'm going to use. 1, 0 is pretty easy. 4, 1 is nice, and 1/4, and then I'm kind of seeing a good enough picture there. There we are. Sorry about that drawing there. That would be f of x. Right, it's not exactly the one they asked me to draw, though. I'm now going to take a different color and move this thing over 2 to the right. So I've got 1 point there, 1 point there, 1 point there. Each point is going to go back to the right 2 units. Got to be careful about that last one. Remember, it's at a 4th, not at the line there. So what we see is this. Oops. Stop that. This kind of graph. All right, and even the points down here are going to go back 2 units. So what happened to our asymptote? Well, this is g of x. G of x. All right, so what has happened to our asymptote? Once again, we see that if it's not transformed, the f of x function, it's still centering around 0. But now that the whole thing has moved right too, the asymptote has also moved right too. So we are at x equals -2. Now let's check out that relationship here. I had a x minus 5, my asymptote became 5. I have a x plus 2, my asymptote was -2. So there is a bit of an opposite relationship there. Watch out for that. But if you want to bank on that, you can as well. All right, a couple more here. Here is the next kind of transformation. This is a slightly different transformation. Notice there is a distinct lack of parentheses here. There's no parentheses around this x, which means it's applied second. It's not x plus 6 and then the log. It's the log and then plus 6. And so this performs an up and down transformation. In this case, up 6. But we're going to kind of go the same route. We're going to graph log base 2, aka 2 to the x equals y. So -2, -1, 0, 1, 2. 2 to the first is 1. 2 to the 0 is 1. 2 to the first is 2. 2 to the fourth is 4. 2 to the second is 4. Flip those over, 1 over 2 and 1 over 4. All right. We get the points 1, 0, 2, 1, 4, 2. And then some guys down here. And I'm not going to connect these points because I know that's a waste of time, right? This isn't the function that I've been asked to graph. This is an f of x function. I'm going to take each one of these and I'm going to move up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Careful with these guys. They're not going to be up onto the line. Onto the axis, onto the y-axis there. They're still going to be off the y-axis a little bit. But this is my logarithmic function. Okay. Now notice on this one, it doesn't look like the asymptote changed. We did not shift that x anywhere. We just shifted the y values. And so that asymptote, the line that it's bordering, did not change. It's not going to suddenly whoosh off to the side there. Nope, it's just going to stay right where it is at x equals 0. Sweet. All right, these last three, we're going to look at a combination of functions. Pardon this typo here. This should be f of x equals log 1/2 of all that other stuff. I highly recommend you try these out on your own. They're just combinations, but they just happen at the same time. So looking at D here, This would be a right 3 and up 4. All right, I'm going to go ahead and do this now. If you want to stop the video and try it on your own, I highly recommend it. Okay, so hopefully you have time to pause the video. If not, that's okay. I'm going to start by graphing log base 2, which we just did. I don't know why I wrote it that way, but that's okay. 2 to the first would be 1, 2 to the second would be 2, 2 to the fourth would be, to the second would be 4. Then flip those two over. We get that same set of 4 points as we did a moment ago. 4 and then squish. Okay, but now they're right 3 and up 4. So now I'm going to take them right 1. I'm going to go 1, 2, 3, up 1, 2, 3, 4. Now another little trick you can do is kind of mimic the pattern. For us pattern seekers, I see that this first dot here is 2 over and down 1, and that would still be the same over here. It would still move at the same amount. This is now 1 over, so there. I'm going to go ahead and erase all that because that's ugly. And then it goes down a little bit and a little bit. So visually you can move the whole graph over at the same time. That's great. If you need to move each point individually, that's fine too. What happened to our asymptote here? We get, it was vertically shifted. Yes, that doesn't affect the asymptote though. What actually affects it is horizontal. We did have to move that x over 3, and so we move our asymptote as well to x equals 3. Sweet. All right, function notation. We've seen this already. We don't need to worry about it because we in fact used it to distinguish. Now we're calling this line f of x. No big deal. Okay, whoops. There we go. I'm going to go ahead and graph log base 3, -2, -1, 0, 1, 2, 1, 3, 9, flipped over. We get out 1, over 3, up 1, 9, 2, and then the little guys. This function is going right 2 and up 5. So right 9 going right 2 makes it off the page. So right 2, up 1, 2, oh, down 5, pardon me, right 2, and then down 1, 2, 3, 4, 5. And again, I'll use that spacing idea. And then there, and then there. So now we're looking at this guy here. All right, sorry. We now have an asymptote because we did move at x equals 2. All right, last one for this section. 1/2. So this is kind of, if you want to consider it a challenge, you can. It's got kind of a double feature to it. We have to start with the 1/2 base. Remember, you can have fractional bases in this guy. 1/2 to the y equals x. So I'm going to choose those same y values. What would that get me? Well, 1 would actually get me 1/2 this time. 2 would get me 1/4. No matter what, anything to the 0 is 1. Now when I flip, I get the whole numbers. So if you want to think about this as an upside down log base 2, you could do that as well. I get, instead of, so I still get 1, 0, but instead of out 2 and up 1, I get out 2 and down 1, out 4 and down 2, and I get this guy, I get these set of points. But even these points have been transformed. These points have gone left 4 and down 1. So left, I'll start with this one, 1, 2, 3, 4, oops, and down 1, forgot about that. Left, 1, 2, 3, 4, and down 1. Left, 1, 2, 3, 4, and down 1. And then this guy would be like there, and that guy would be there. Okay, and we see this guy, and he'll probably hit 8 somewhere over here, but that's okay. We're rough sketching, right? What is the asymptote here? We still see an asymptote shift, even though it's a y. It's kind of a flip anyway, a flip over the y-axis. The asymptote shift is the same. X is not centering around 0 anymore. It's actually moved over back to -4. That would be the asymptote. Okay. Draw any conclusions you want to about the asymptote and a horizontal shift. I'm sure they will be very helpful. But that is how we graph logs and how we graph transformations of logs. If you have any questions at all, seek out your teacher. Otherwise, I'll see you in the next video.